Hello and welcome back to Chapter 9. We're going to continue Section 9.2 today, talking about hyperbolas. We are going to talk about how to change hyperbolas from general form into standard form. So general form for a hyperbola is similar to what we had for general form for a circle and an ellipse. So we have this form, which looks the same as the ellipse. It's ax squared plus cy squared plus dx plus ey plus f equals 0, where a, c, d, e, and f are all constants. That means they're just numbers. However, a and c, these two numbers can't be 0. We have to have both an x squared term and a y squared term. But what makes these different from an ellipse is it's a hyperbola when a and c have different signs. So that's when one of these is positive and one of them is negative. That's what will give you a hyperbola. Now, to change it into standard form, from general form, we're going to do a very similar approach that we did for circles and ellipses. So for this example here, we're going to identify basically the everything, the center, the foci, the vertices, and the equations of the asymptotes, and we're going to graph this hyperbola right here. So the first thing we need to do is change it into standard form. So just like an ellipse, I'm going to, I'm going to group the x's together. So I'm going to write 9x squared minus 54x, and then I'm going to group the y's together, minus 4y squared minus 40y, and then I'm going to move the 55 over to the other side. I'm then going to complete the square twice. I'm going to complete the square once for x, and I'm going to complete the square once for y. Okay? But what I need to do here, and you should always do this here, when you've got a negative number here for one of your squared terms, I'm going to change this subtraction problem to adding the opposite there and there. So I'm going to change that subtraction to addition by adding the opposite. Because what I need to do here is my first step in completing the square is to make a 1. So I want this number to be a 1, but I also want this number to be a 1. Which means I can't divide to make those both 1 at the same time. I'm going to use the same approach I used for ellipses, where I factor out a 9 from these first two terms. So basically I'm going to group these first two terms together and factor out a 9. So I factor out a 9, so 9 divided by 9 is just 1, and then 54 divided by 9 is 6. And then I'm going to leave myself a blank here for a number I'm about to add. Now in this step though, this is still a plus sign, and then what I'm going to do is I'm going to factor out not a 4, but I'm going to factor out a negative 4, and this is the key step that makes this different than ellipses, and this is what most people, the most common mistake here, is you have to factor out a negative number, which makes this now positive y squared, and this negative 40y divided by negative 4 becomes positive 10y. So that's the key step, is to make sure that you're factoring out a negative here. Then I need to complete the squared by adding half of b squared. So half of negative 6 is negative 3. Square that, I get 9. Then I have to add the same thing over on this side to keep it balanced. But if you remember, just like when we did ellipses, this isn't really a 9 because it's also being multiplied by 9. So really, this number that I just added to this side of the equation is an 81 in disguise as a 9. So I have to add a 9 times 9, or 81, to this side to keep it balanced. And then here I do the same thing. I add half of b squared. Half of 10 is 5. Square that, and I get 25. But I don't add a 25 over here to keep it balanced because this isn't really a 25 because it's being multiplied by, and this is where you have to be careful, it's being multiplied by negative 4. So really, I just added a negative 100 to this side. But it looks like a 25, but it's being multiplied by negative 4. So to keep this side balanced, I need to add negative 100 to this side. So be careful with your negative signs here. All right, next, this is factorable into x minus 3 squared. This is factorable into y plus 5 squared. That's the whole reason I added those numbers, is to make that happen. Then I have to add all these numbers together on the right side. 55 plus 81 plus negative 100 is 36. I then, to get it in standard form, need to divide everything by 36. So I divide everything on both sides by 36. Now this fraction here is 9/36, which simplifies to 1/4. This plus a negative I can just change back into subtraction to make it look like the standard form for a hyperbola. And then I simplify, 4/36 becomes 1/9, and then 36 over 36 is 1. And I now have the equation for my hyperbola. So the next thing I'm going to do here is, before I identify all these, I'm going to actually graph it first, because I think drawing the graph helps me identify all those parts. So I'm going to start with the center at 3, -5. So I start with this point right here at 3, -5. And then in the x direction, from the center I go 2 units to the right and left. And then in the y direction, the square root of 9 is 3, so I go 3 units above and below, and that helps me draw this rectangle here. I then draw my asymptotes through the corners of those rectangles, like so. I then have to decide which direction the hyperbola is going to face, so I look at what terms first. Since x is first and y is second, that means it's going to open up in the x direction, which is going to be to the left and right, so I draw my curve within those asymptotes using those dotted lines. So there's my graph. I'm then going to identify all those parts it asked me to. So the center we said was at 3, -5. The vertices you can see here are at 1, -5 and 5, -5. And then next, to identify the foci, I need to use this equation, a squared plus b squared equals c squared. So A and B are these two measurements. A is the one with the vertex, that's half the transverse axis. B is the other one, that's half the conjugate axis. So it's going to be 2 squared and 3 squared in there for A and B. So then c squared is 13, so c is the square root of 13. And then the foci are going to be inside these hyperbola curves here. So the foci are going to be somewhere like here and here. So that's going to be to the left and right of the center, which means I take that value and I add or subtract it to the x coordinate of the center to get that the foci are at 3 plus or minus the square root of 13, comma, -5. And then I think the last thing it asked for was the, let's see, center, foci, vertices, equations of the asymptotes. So the asymptotes, again, are going to be lines. I'm going to use point slope form. They go through the center, and they have a slope of, and this is where I like to use my graph rather than memorizing whether it's A over B or B over A. I just look at my graph and say, okay, that's a rise of 3 and a run of 2, so that's going to be 3 over 2. So I plug all that in. The center, x minus 3 goes there, y minus -5 or y plus 5 goes there, and then the slope is 3 over 2 goes there, and this is the point slope form. This plus or minus is for the two different lines because one of them has a positive slope through that point, one of them has a negative slope through that same point. So there are the equations of the asymptotes. So you can see for this one problem there's kind of a lot to do, so you don't have many homework questions, but there are a lot of steps for each one. So if you have any questions, of course, let me know and I would be happy to help you out.